Technology has come a long way over the last century. For the majority of our human history, technology derived from the human brain, with the exception of fire and sharp objects. Each new technology serving various purposes in our lives. Clearly, some examples are more important than others. From the 1960s, the computer has kept developing exponentially, facilitating size reduction with greater levels of power occurring virtually overnight. A computer is constructed from relatively simple parts undertaking rather uncomplicated actions, from presenting data, processing and manipulating computation, and controlling certain mechanisms. Computer chips contain modules that themselves contain logic gates, typically containing a transistor. A transistor is an uncomplicated form of data processor in the computer, which is basically a button that can be either block or open a gate for information to pass through. Such data manipulation at binary level based 2 format. With the recent innovation of quantum computing, scientists have been trying to understand quantum computing world. So what is a quantum computer? A quantum computer is a type of computer that uses quantum mechanics, so it can perform certain kinds of computation more efficiently or effectively than a conventional computer.
When it comes to computer problem solving, even our current faster computers cannot compare to a quantum computer. Typically, a quantum computer can perform up to 100 million times more rapidly than a conventional computer when it comes to problem solving. A quantum computer uses quantum bits, also known as qubits, whilst the conventional computer uses binary bits, 1 or 0, as a process of calculation, which is so much slower than a quantum computer. A qubit is a rudimentary unit of information in a quantum computer. In a quantum computer, a variety of particles, like electrons or photons, can be utilized with one or others of their charge or polarizations as a substitute for 1 or 0. These individual particles are termed a qubit to the way these particles behave when presented in the form of quantum computing. This continuum, therefore, forming the basis of such computing. The two significant characteristics of quantum physics are the fundamentals of superpositions and entanglement. What exactly is a superposition and how does it work? Imagine a qubit as an electron in a magnetic field. The electron can either spin in the same orientation with a field, which is a spin-up state, or alternatively spinning opposite to the applied field, which is known as a spin-down state. To achieve this variability of the electron's spin from one state to the opposite by using a simple but measured pulse of energy. The pulse energy is simply the total optical energy contained of the pulse, i.e. the integral of the qubit, optical power over time. For example, introduce the notion of the use of laser. Let's say we use 1 unit of laser energy. Although, if we use 1 fraction of unit laser energy and ensure an absolute segregation of the particle from the outside effects? Well, as presented by the quantum law, this particle then becomes elevated to a position of a superposition state, at which time this particle behaves as if it was in both states simultaneously. The individual qubit could therefore take a superposition of both 1 and 0. Therefore, the number of computations that a quantum computer could undertake is 2 to the power of n representing the numbers of qubits used. A quantum computer consisting of, say, 500 qubits would have the potential to undertake 2 to the power of 500 calculations. This number, 2 to the power of 500, is rather miraculously number in that the product provides a number that is infinitely greater than the number of atoms in the known universe. Nevertheless, how would these particles interact with each other? In principle, they would do so via the process of quantum entanglement.
The individual particles that have interacted at some point in time, maintaining a type of link that can be entangled with other individual particles in pairs, this process has been known as correlation. Given the non-spin state of either an entangled particle, either up or down, this allows us to determine the spin of its colleague is in the opposite fashion. What's even more amazing is that to the occurrence of superpositions, the measured particle does not have any single spin direction prior to its dimension being measured, although the particle's spin is simultaneously in both a state of spin up and spin down contemporaneously. The spin of the particle being measured is determined at the same time of measurement and communicated to the particle at this time, and which also simultaneously presume the opposite spin direction to that of the measured particle. This is a real phenomenon. Einstein called this spooky action at a distance. This is something that at this stage cannot be explained yet, although some scientists are still attempting to unravel the mystery. Quantum entanglement grants qubits the facility of being detached by an absurd amount of space to interact with other individual particles immediately. In simple terms, no matter how significant the distance between the correlated particles, they will maintain an entangled phase as long as the two particles are isolated. Generally speaking, quantum superposition and entangle generate an extreme enhanced computing power. In an ordinary computer, a 2-bit register can store either one of the 4 binary arrangement 00, 01, 10, 11 at one time. However, a 2-qubit in a quantum computer can store all the number at the same time. This would mean that if the qubit were to be added, this would allow the computer to increase its work capacity exponentially. There exist many possible applications for quantum computers, such as cryptography, aviation, data analytics, forecasting, pattern matching, medical research, and last but not least, self-driving cars. Having said that though, the most common function, though, is that a computer can tend to lean toward advanced cryptography. With a typical modern computer we all use currently, it would take virtually impossible to crack encryption that would use an enormous prime number factorization, 300 or more integers. This level of encryption could become insignificant when quantum computer could be ready to use for mining. This would lead to significantly stronger interpretation and protection of digital data. Secondly, quantum computing can be beneficial to help solve problems on a large scale. There's a field of study called topological analysis where geometrical shapes behave in certain ways, such behavior being simply impossible to interpret with current computing facility due to the significant quantities of data being utilized. However, with the quantum computer, this pursuit can be much easily undertaken with much simpler levels of calculation. Currently, NASA is seeking to utilize quantum computing to analyze the relatively gigantic level of data which they have collected pertaining to parts of the known universe, and to therefore research better and safer ways for humans to undertake space travel. Pattern matching is something a quantum computer could effectively utilize in order to predict future pattern matching using the data provided. Currently, Volkswagen is seeking a way to utilize quantum computing to notify the drivers of pending traffic conditions, particularly in advance. This function being something a modern conventional computer can't comprehend, let alone manage. All appearances, however, this would suggest that everything will be changed with the introduction of a quantum computer. One of the far-reaching practicalities of a quantum computer is its application to medical research as today. It takes pharmaceutical companies often more than 10 years and sometimes many hundreds of millions of dollars to be invested to design new drugs. By simply refining the front end of development with quantum computing, this could potentially reduce the cost as also the time it takes to research, test, and finally hit the market. Potentially, as a result of this drug development, this could significantly increase the human lifespan if this particular drug was more refined. And lastly, the future we have been waiting for, and as for some referred to in various movies, could be on our doorstep. Would we have believed it was possible to have self-driving cars 10 years ago? Certain car companies, such as Tesla, and some tech companies, such as Apple and Google, have been and are continuing with research, undergoing and developing driverless cars. This not only will improve the safety of managing traffic, but will likely to cut down pollution and diminish congestions and bring a cluster of other benefits. Google and Volkswagen are currently using quantum computers to develop battery, self-driving technology, and transportation. At the moment, Volkswagen has already optimized the traffic flow for 10,000 taxis in Beijing and are heading for more development with quantum computing. Whilst we weren't able to see the full potential of quantum computing for some time yet, although with the early research and current operation, we as a society are already noting astonishing potential and benefits with our realization of quantum computing. There's a downside to the quantum computer, is that it coherent spontaneously disappears over the course of time, and with this, the store information as well. This could pose a considerable problem for the development of quantum computer in the future. Quantum computers are great for many purposes, but for the time being, we won't know if quantum computer will be just a specialized tool or perhaps a significant revolution for humanity. Currently, we don't have a clue as regard where the limits lie with current technology, and for the future, there remain so many more yet to be discovered.